Welcome back Year 5 to day 4 of our calculation focus week. Here are today's calculations to practice your fluency. Choose your colour, do the calculations, pause your video, and then when you're ready to check your answers, you can unpause and I'll bring the answers to you. Okay, here are your answers for today's calculations. Right, I also have for you the answers to yesterday's task. So now there were quite a lot to do, so I'm going to put one sheet at a time, so you might want to pause and check your answers. There are the answers to questions 1 to 4. Then here are the answers for 5 to 8. And last of all, 9 to 12. So hopefully I've included enough detail in my answers, along with some bar models as well, to help you check your answers. Okay, today we're going to move on to multi-step problems. So these are the same as yesterday, using the same strategies as yesterday, but this time we're thinking about maybe doing 2 calculations in one. So let's have a look at this problem and we'll talk about how we might tackle it. This table shows the height of 3 mountains. How much higher is Mount Everest than the combined height of the other 2 mountains? So using our strategy of keywords, I'm going to look at this, combined height. Now combining is bringing things together, so I'm going to add the height of the other 2 mountains, which are these 2. Okay, so I'm going to add 5,895 and 1,344 first. So I need to know that first. So that is step 1. Okay, so I'll do my calculation, and of course you might use an inverse to check. 8, 9, 10, 11, 12 hundreds, 5, 6, 7 thousands. I am going to do a quick inverse here to check. As we know, I am prone to making mistakes. 8 and 5, yep. Okay, so the combined height of the 2 mountains is 7,239 meters. Okay, and now part 2 of my problem is how much higher is Mount Everest? So now notice how I'm using a range of strategies here. Here's Mount Everest, which is 8,848 meters. And here is a bar to represent Kilimanjaro and Ben Nevis, which I know is 7,239. And I want to know how much higher. So it's this gap here that I want to work out. And I can see that what I need to do is do 8,848, take away 7,239. As is often the case with maths, there are lots of different ways you might do this, lots of different strategies. I'm just showing you an example. 8 take away 9 we can't do. We're going to exchange. 18 take away 9 is 9. 3 tens take away 3 tens. 800s take away 200s. 8,000 take away 7,000s. So Mount Everest is 1,609 meters higher than the combined weight of the other 2. So when you have a multi-step problem, you can see how you can use a range of strategies we've used this week. It already was in a table for me. I used that to help me. I highlighted keywords, I checked with the inverse, and I did a bar model before I actually solved the problem. So you might choose one method, you might choose a combination. Let's have a look at another one. Oops. Okay. Ooh. Amina posts 3 large letters. The postage costs the same for each letter. She pays with a £20 note. Her change is £14.96. What is the cost of posting 1 letter? Oh my goodness, there's a lot there. Right, first of all, we know that all the letters are the same. Let's work out how much she spent first. Okay, so it tells me how much she had and how much her change is. So I know when you've got the word change, you're doing a subtraction. So she started with £20 and she spent £14.96. Now I'm hoping you've spotted that that's nearly £15. So we don't need to do a written method for that one. 4 more pence will take that up to £15, and then £5 will take it again. So it's £5 and 4 pence. Remember, 4 must go in the ones, don't accidentally put it in the tens. So she spent, Amina spent £5 and 4 pence. Okay, but that's not the question. The question says, what is the cost of posting one letter? So we need to go back at the top of the problem. She posts 3 letters and the postage cost is the same or equal. So £5.4 is going to be shared between 3 stamps. So I'm going to do a division. I'm going to divide by 3. So I am going to do a short division. Again, if you want to do a different way, you can. So that's £1.68 each letter costs £1.68 to send. And I could check it by doing 3 lots of 168, adding on £14.96 and making 20. Okay, let's do one more together. And what you might want to do is pause and have a go first and then see how I solve it and see if you've got it the same. Okay, Layla makes jewellery to sell at a school fair. Each bracelet has 53 beads. She makes 68 bracelets. Each necklace has 105 beads and she makes 34 necklaces. How many beads does she use altogether? So I'm going to split this then into bracelets and necklaces. Okay, so let's do the bracelets first. So she has 53 beads on a bracelet and she's got 68 of them. So it's going to be 68 lots of 53. Okay, so 68 times 53. Just solve that quickly. And while I'm doing it, you can just check that I'm doing it correctly. So 3 times 8 is 24, which is 4 ones, 2 tens. 3 times 6 tens is 18 tens. Add those 2 tens, it's 20 tens. 5 tens times 8, or 5 times 8 is 40, so it's 40 tens, which is 4 hundreds. 5 tens times 6 tens, well 5 times 6 would be 30. 5 tens times 6 would be 300. 5 tens times 6 tens is 3,000. I've got 400 there. Now, the biggest problem when you do something like this is your place value. So what you could do is just do an approximation to check. So 68 is very close to 70. 53 is very close to 50. So I could do 70 times 50 just to make sure I've got my place value right there, because it can be tricky when you're doing a 2-digit number. So I know that the bracelets was 3,604 beads. Let's do the necklaces. 105 times 34. Now, I'm actually going to do this mentally and talk you through how I do it. So 100 times 34 is going to be 3,400. Remember, when you times by 100, you move along 2 places to the left and fill in any gaps with zeros. So that's 34 times 100. 34 times 5, times it by 5 is easy if you know how to times by 10 and half. So 34 times 10 is 340, and then I have to half it to give me 170. Okay, so 5 times 34 is 170, and then I just add those together. Absolutely fine if you decided to do that as a written method, no problem at all. Just talking about different ways you might. Of course, we could do a written method to check it as well. I've done a lot of calculation, but I haven't actually solved the problem yet, because the problem says how many beads does Layla use altogether. I know how many beads she used for bracelets. I know how many she used for necklaces. I now need to finish off by adding them together. Okay. You can spot, can't you, that when you do a multi-step problem, there's lots and lots of opportunities to make little mistakes. So it is important to show you're working out, so hopefully you can go back and unpick if you need to. So I think the answer is 7,174. I'm sure you could check it for me and let me know if I've made any mistakes. Okay, today you're going to do what we've just done in practice, solve some multi-step problems. Now there are 4 sheets here because the problems take up quite a lot of space. have a go, see how far you get. Now what I'm going to do is I'm just going to put sheet 1 there for you to pause and have a look at if you want to. I'm going to slowly go through each sheet. They are available on the website if you need them, and I will make sure they are on the PowerPoint as well if that's how you're learning. So there's page 1, page 2, page 3, and page 4. Okay, quite a lot of problems to solve there. Do what you can. If there's one that you're finding particularly hard, miss it out, and when we go through the answers or when I show you the answers tomorrow, hopefully you'll be able to see how you could have solved it.